So I'm going to talk about, can you hear me if I'm not standing up by the microphone? Okay. So I'm going to talk about job displacement and wage status trajectories. This is some work I'm doing with Jack Iwashna at the University of Michigan. And this is very much definitely a work in progress. We're still trying to figure out how best to both manage and analyze these data. So I would definitely welcome any comments, suggestions, critiques you have, and feel free to stop me along the way. Noreen says that's not your culture here, but please do stop me if you want to. Just raise your hand. Okay, so as everybody knows, there's a big and well-established literature on social gradients in health. People of higher SES have better health outcomes on a variety of health measures, and this is certainly also true of weight status. There are inverse gradients between SES and weight status, but the interesting thing with this outcome is that the gradients are primarily among women, and they're often strongest among white women. So that's a little bit different than some of the other health outcomes. And as you can imagine, there's uncertainty over the contribution of, is it SES causing something about weight status, or is it weight status cause something about SES? And they're difficult to disentangle because this is essentially a reciprocal relationship. So part of our what we're doing today, can you see that, is to focus it on this causal arm a little bit by looking at job displacement, in particular layoffs, as a plausibly exogenous source of change in SES. So before I get into the data stuff, I just want to do a little background on what the relationship between SES and BMI looks like. These are BMI over here on the y-axis. This is poverty-income ratio. These are just data from the NHANES that we looked at a couple years ago. This is NHANES 1 and 2, which are from the 70s. NHANES 3, which is from the late 80s and early 90s. And then this is, at that time, the most recent data from the NHANES continuous. This is white, whoops. This is white women, non-Hispanic white women. And what you see is that there's a pretty persistent inverse gradient that persists through the years. The slope is remaining relatively constant as the intercept just goes up. And the wealthiest women from today are starting to weigh as much as the poorest women from the 70s, but they still have a much lower average BMI than the poor women in their contemporary survey. This is the same data for non-Hispanic black women. And we see that there's here, too, there's inverse gradients, perhaps not as steep as it was for white women. And the only difference is this y-axis here is shifted up by 3 BMI units compared to white women. And then here's Mexican-American women who were oversampled in NHANES 3 in the continuous. Again, an inverse gradient, but probably not as steep as it was for white women. And then this is what it looks like for white men. So clearly more flat in the early NHANES, possibly a little inverse gradient developing in the latter two surveys, but clearly not as steep as it was for white women. And when we looked at black and Mexican American men, there's actually a positive gradient emerging in the latter ways. Okay, so there's a lot of studies showing what I just showed you, right? There's an association between SES and weight status. Most of them are in cross-section, as ours was. And they're generally operating under the assumption, or they're explicitly framed in terms of some kind of causal relationship of the effect of SES on weight status. So weight status is usually the dependent variable in the model. There are multiple potential explanations for this causal pathway. Many of them relate to things to do with income in terms of its effects on food and nutritional quality, neighborhood effects, et cetera. There are a lot of different things. I'm sure most of you are familiar with, many of you are familiar with most of these potential factors. Now, there's also the flip side, a smaller literature, mostly from economists, where weight status is the predictor variable. And it's suggesting that weight status, or obesity per se, has negative effects on a number of different social outcomes. So we have marital status, education, income, wages, and employment. So people who are obese are less likely to be married, have lower educational attainment, lower income, lower wages, and are less likely to be employed. Interestingly enough, these associations are also primarily among women, and they're often only among white women, or much stronger for white women than the other subgroups. So I've argued, and I think it might be true, that compared to other health outcomes, there might be a larger role here for the effect of the health on SES. Because if you think about it, unlike other illness states, obesity is something that it's immediately visible on your body. It's highly stigmatized, especially for women. And given its strong ties to appearance and things like social status, people might actively invest in their weight status or changing their weight status for the purposes of social mobility. And the large sex differences we see, sex and racial differences, right, certainly speaks against some simple explanation in terms of the material benefits of income or education as the primary drivers. On the other hand, it seems intuitively obvious that things like education and income should affect weight status along some of the same pathways that it affects other health outcomes. Okay, but the broader point I want to make is that, regardless of whether weight status is cast as a cause or effect, right, most of the prior studies don't give us much traction on causality or causal direction. And this is primarily because of two rather generic estimation problems. One is confounding from unobserved factors, which I think might be, especially salient here. So if you think about things like personality or behavioral dispositions, self-discipline, self-esteem, time discounting, goal orientation, right? These are all things that can affect both your SES and your weight status, and therefore create some kind of spurious association between the two. Many of the studies on wages from the economists have tried to address this by using family fixed effects, twin studies, this one by Jerry Bierman, individual level fixed effects, right? So this is trying to difference out any shared component in family environment or genetic endowment. But this isn't going to be effective if these confounders are changing over time, and it doesn't really address the issue of reverse causality, which is the second estimation problem. So John Cawley has done a number of papers where he wants to know the effect of BMI on things like wages or other outcomes, employment, disability. And what he does is he instruments BMI with weight from a genetically related family member. So here in this study in 2004, he was using sibling weight to look at the effect of BMI on wages. He's also used the weight of one's child. And interestingly, he also finds strong effects among white women. So John and I have gone back and forth, a bit on this. I think there are some issues with the validity of using a family member's weight as an instrument. It depends on, what you think the problems are and how to solve those problems. So we can certainly have a discussion about that afterwards if you would like. But I don't happen to think family members' weight is a great instrument. But it's subject to disagreement. Okay, so we're taking a slightly different approach. We're going to look at job loss due to a layoff or plant closing as a plausibly exogenous source of SES change. Layoffs are, by definition, not supposed to be related to your job performance or other personal attributes. Plant closings are probably even more clearly exogenous. And if they're truly exogenous, right, they're going to address both the problems I just discussed in the previous slide. So both unobserved heterogeneity and reverse causality would be addressed by an exogenous change. And, the labor studies generally find that there are income deficits sustained a long time after a layoff. So even over 5 years after you've been laid off or had a job displacement, you have income deficits, even if you get reemployed because you're underemployed or you don't make as much as you did in your new or next job. Okay, so one of the things we're doing is to trying to get some insight into the causal effects of SES on weight status. But we're also quite interested independently in this effect of job displacement, the relationship between losing a job or getting laid off and your weight status as an independent question. So, given the current economic climate, there's definitely strong interest in the consequences of job displacement. Most of the focus has been on health insurance and poverty, and there's much less attention to health itself, no less wage status. And we think, looking at weight changes is important because weight gains are hard to lose, right? It's easy to gain weight, but it's hard to lose weight. Some of this has to do with potential metabolic changes. Some of it is just behavioral stuff. And weight can change faster than other health states. But it has strong implications for longer range, longer term health stuff. So it could be that if you're looking at the health effects of acute economic shocks, a change in weight might be one of the first things you see in a larger sequence of events that happens later. Okay, the data we use are the National Longitudinal Surveys, which I'm sure many of you are very familiar with. It's a nationally representative sample. It started in 1979. It goes to 2010, which is currently the latest wave. They were interviewed, it's a cohort, they were interviewed annually from 79 to 94, and then every 2 years up to 2010. There were 12,686 people at baseline. They were age 14 to 22. They were born from 57 to 64, and these people are now, in 2010, they were in their mid-40s to early 50s. Retention rates are generally considered among the best for the NSLY 79. They, with very low attrition, so they were 90% or greater through 94, the retention rates. They were still 78% in 2008. And they're 50% higher than the PSID by the 12th interview. And response rates are also quite good. This is if you kick people who died out of the denominator, 90% or greater through 94 and still 82% in 2008. And it has data on stuff we need or are interested in, standard sociodemographic stuff, self-reported height and weight, a rich compilation of labor market employment variables, and this weekly work history data, which we're also going to use. So they did measure weight in every survey wave in the beginning. So it's available for these years in the 80s, and then every 2 years they did it starting in 1990. So we have a total of 18 survey years where we see their weight status. Their primary outcome is going to be body mass index computed in standard fashion. And we're going to restrict the analysis to weight observations where people were at least 18 years old. And the NSLY was an in-person interview in over 90% in the early years, and it was still 68% by the year 2000. And I just mentioned that because of the self-reported height and weight issue. I mean, there are ways to adjust for that, which we haven't done in this preliminary round, but it's much harder to grossly exaggerate your height or weight during an in-person interview. Okay, so this is just a picture of what's going on with the distribution in this cohort. So this is 1985. This is distribution of BMI, 1985 and 2008. So they are getting older and they are getting bigger, heavier. So the mean has gone from 24%, BMI of 23.7 to 28.6. Overweight from 22% to 38, and obese has gone from 7.7% to 36.1%. So big age, well, this is a cohort, right? So it's a combination of age and period effects. So what I did here was I took data from the NHANES, which is measured height and weight. I took data from the NHANES from the continuous survey 07 to 08. I looked at people that were well, actually, I grabbed it from a publication, 40 to 59 years old, which is approximately near how old they are here. And the prevalence of measured obesity is 34 for men and 38 for women, which is not too far off from what we see in the NSLY, self-reported. Okay, so there's this issue of how do we find the layoffs? So in every wave, they collect data on all new and previously reported employers for whom they have worked since the last interview. Okay, there's data on up to 5 jobs in every wave. In the later waves, they can go up to 9 or 10, but very few people have more than 5 jobs. And for each of these jobs, 1 through 5, they ask them if they're currently working at that job. If they said no, they ask them the reason they left that job. Layoff is a potential answer in all years. In 84 to 2000, they could have also said it was from a plant closing. And then from 2002 until 2010, that plant closing option changed to company, office, or workplace close. And most importantly, we have information on stop date, which is the actual date they left that job, which allows us to time this leaving of the job with their interview date and when their BMI was assessed. So basically what the analysis done is they've created this continuous work history up to the most recent interview. So if somebody skipped 1 or more interviews, that intervening information is still captured because they frame all the questions in terms of what happened since the last interview. This also allows them to build this weekly labor status array going from the very first week, January 1, 1978, until the most recent interview, the last time they were seen. So there are weekly data on over 1,700 weeks on some people in the survey at this point. Now, just as an aside, there's, these data are very messy and complicated, so if anybody has experience and you want to interrupt with comments, please do. There's also information on within job gaps. So this is if they consider themselves still associated with the employer, but they could have also said they had a layoff with the, under the within job gap category. But our focus today is going to be exclusively of when they said they left the job. Okay, so if you think about this and what we're trying to get at and how the data are set up, there are some issues that can come up. So maybe there are issues, maybe they're not. So one is that the situation of multiple jobs. So people can have multiple jobs, which means they could still be employed at some job when they said they were laid off at job 2. They could still be employed at job 1, and maybe this doesn't matter as much if they still have another job. So one restriction we entertained was taking that weekly labor status information and requiring that for something to count as a layoff for us to look at, they had to be working for 4 weeks prior to when they said they got laid off, and there had to be a coinciding change in their labor status to unemployed or out of the labor force for the second 4 weeks. The second problem is that they could be laid off from a job that wasn't actually that substantial. Maybe it was a temp job or a part-time job, or maybe it didn't pay very much and it just doesn't matter that much. So we entertained a second restriction, which was relating to tenure and time. So tenure, we wanted them to be working with that employer for at least 4 months, and we wanted them to, the average number of hours per week they usually work at that job had to be at least 20 hours. Okay? So there's a lot of ways to try to restrict this, to get around these problems. These are just 2 of the ones we're doing right now, and we're going to look at it with and without these restrictions, because, you know, even if you have 2 jobs, maybe if I lost one of them, maybe maybe that's still meaningful to me. Maybe I really needed those 2 jobs. It's hard to know. Okay, so we found a lot of layoffs, or people answering yes to layoffs. So there are 12,000 some people across 24 survey waves, okay? And we found a total of 21,588 layoffs as an event. So this is a, unfiltered, just people saying they got laid off. And among those 21,588, 88% they said it was a layoff, 9% they said it was plant close, and another 3% said it was company, office, or workplace close. Yeah.
You must also have data on whether they report that they were fired. So do you know if there's any kind of bias for people who were fired saying they were laid off?
There undoubtedly is, but there is a fired category.
And do the numbers of it look like what you expect?
Well, I'll show you. It's debatable. So I've asked some economists about this, and these data do cover 2 periods of big recessions in this country, one in the early 80s and one in the most recent period. And if you look year by year at the layoffs, they do bump accordingly with the recessions. if you take all the people in the survey and you look at how many events they experienced over the course of the survey, this is what we find. So 34% of people didn't have any events, 25% had one event, 16% had two, so on and so forth. So my feeling was this seems like a lot of layoffs. So what happens if we impose that first restriction? So the first restriction was requiring that that layoff show a discrete change in employment status from employed to unemployed. So if we do that, restriction 1, it drops the number of layoffs done by quite a significant margin, down to 12,000. And now there are only 50% of the people have experienced an event. So that's a big drop. What about that second restriction, requiring that this job was more serious in terms of the amount of time they spent with that employer and the number of hours they work? If we do that, it's almost the same proportion drop as the first one. And again, now 50% of people haven't experienced an event. So maybe they're picking up something a little bit similar. Okay, so this is the main model. WIT, so this is repeated observations within person. WIT is their BMI for person I at time t. And the key predictor here is this vector of layoff dummy variable, layoff indicators. So D1 IT is if this person I had a layoff during the first interval prior to when we saw their weight status. D2 is if they had a layoff in the next interval prior to weight status, and ongoing backwards from weight status. Okay? And these, we can vary the time length of the interval, so we're going to look at 4, 6 months, or 12 months yearly. And why do we do this? Because it allows this effect of the layoff on your weight status, WIT, to have a time path or shape, right? So I get laid off, it has some effect on my weight. It could be immediate or delayed. If it's delayed, we're probably not going to see anything until like D3 or D4, right? It's going to be farther out. It could be permanent, or it could be transitory, right? So if it's transitory, it's going to taper off as you go backwards. Does that make sense? No questions? Sometimes feel like I have to think backwards to think about this. Like think upside down. I'm not very good at that. Okay. The second piece, and I'll tell you a little bit more later about why we do this, is that we also want to look at layoffs that happen after we saw their weight status. Okay, so we can code these dummy variables the other way. So 1 period after we saw their weight status, 2 periods after we saw their weight status. Okay, so we're going to do before and after, pre and post. There are time constant and time varying covariates here. And this alpha I can be modeled as a random effect, which addresses the issue of clustering within people, or fixed effect, and we're going to look at random effect models first. Okay, so as we said before, there's 12,000 some people at baseline. It's roughly evenly split between women and men. This point here is the actual number of person-year observations with BMI, right? Because we don't have BMI in every year. About 81,000 for women and 80,000 for men. The average number of observations per person we see is 12.7, maximum of 18. As I said before, we exclude observations where they're less than 18 years old. Just a note, there was a discontinuation of some supplementary samples. There was a military sample that was dropped after 1984 and a poor white sample that was dropped after 1990. But among those interviewed and eligible for weight status, there's a very low proportion of cases that are missing weight status. It's just 1 to 2%. Okay, so these are some of the results. So these are the models where those dummy variables are in terms of years. So year 1, before my BMI, 2 years back, 3 years back, 4 years back. These are random effect models. BMI is the outcome, stratified by sex, women versus men, and it's adjusted for age, year, race, and education. And what we see is that there's a significant association in year 1 and year 2 only among women, and it seems to dissipate as you go far back. So it suggests that there is an increase, but it's transitory. And we don't see anything over here for men. The estimates are much smaller, and obviously it's not significant. So we think there's something going on in somewhere between year 1 and year 2. And if you take these out, we don't see anything going forward. So this is, if we break up that 2-year window into 6-month intervals, what do we see? So we don't see anything from 0 to 6 months. That's the first interval. Maybe that kind of makes intuitive sense, right? Because it takes a while to gain weight. This is too close. But here we see positive and significant associations somewhere between 1 and 2 years. And again, tapering off when you get closer to 2 years. And nothing for men. Yeah?
So the taper suggests that they stop gaining weight, not that they're losing weight. Is that right?
Well, this isn't technically about gaining or losing. I'll do a little change weight also, but yeah, that there's an increase above average, but it only lasted for that period of time. This is if we break it up into 4-month intervals. Now, this is, every time we chop it up into a smaller interval, where, things are getting flaky and bouncy because the number of layoffs that we can see are getting smaller. But here again, we see something between this 1 and 2 year interval for women and nothing for men. Okay, what about those post-layoff dummies I told you about? And there's 2 reasons we want to look at this. Post-BMI layoff dummies. So one is that if the results I just showed you before, right, these pre-weight status findings, if they're driven by the fact that people with a higher BMI are somehow more likely to get laid off, there's some kind of selection effect going on, then even though it's not supposed to, because layoffs aren't supposed to have anything to do with your BMI, but maybe there is, then we would see a positive association between your weight status and a layoff that happened after your weight status. Right? Does that make sense? You're going to see a positive association going the other way, if that's what's going on. The second point to think about is that people might anticipate the fact that they're going to have a layoff coming up, right? And change their behaviors in some way that changes their weight. They might anticipate it. They might formally get notice from their employer. And this could lead to decreased spending in anticipation of an income decline. And that income decline could lead to eating unhealthy foods or eating less food. We really don't know what effect that would have on weight status. And the second piece is that people might improve their appearance in anticipation of needing to find a new job, especially women. Okay, so we thought it would be interesting both to explore this and possibly rule that out. So this is what we see if we have both of those in there at once. Okay, let's say this is when you were interviewed and we saw your weight status. This is a layoff 1 year before that. This is the layoff 2 years before that. Okay, so this is what we saw before, these positive significant associations. And this is 1 year after and 2 years after. So this is the same regression. Dramatic contrast between the before and after layoff indicators. So we thought that was a nice finding. Same thing if we just break it up by 6-month intervals. Here's what we saw before, nothing post-interview. Okay, now, what about those restrictions that we put in there? So the idea was that, if we have a lot of unserious layoffs going on there, maybe that's actually diluting our effects somehow, right? Maybe we want to hone in on these ones that seem more meaningful somehow. So just to remind you, restriction 1 was change in employment status 4 weeks before and after, and restriction 2 was the issue with tenure and time, as described. So this is the model we saw before, unrestricted. This is all for women, and this is restriction 1. And maybe it got the estimate, the magnitude got maybe a little stronger, not clear, but not a big difference. Because the N doesn't refer to the number of layoffs, it's the people in the sample. and this is the 6-month version, probably getting a little stronger here. So maybe it is weeding out a little bit of noise, but it's not making a huge difference, despite the fact that we lost like 40% of the layoffs from doing this. We also didn't lose significance. And this is the 4-month version. Maybe a little stronger, not a big difference. And even with the restricted one, you even see a pattern shakeout at 3 months, just getting kind of bouncy. Okay, and what about second restriction with time and tenure? Same thing, maybe a little stronger, but not hugely different. Okay, and this too, when we did the time and tenure thing, we're dropping about 40% of the layoffs. Okay, and then, so those were all random effects models, and then we wanted to know, well, what happens if we impose a fixed effect for each person? So these are comparisons within person. So what you're doing is you're comparing the BMI observations. So for any one person, you're comparing the BMI observations where they had a layoff to those periods of times when they didn't have a layoff. So as you know, all time constant factors, regardless of whether they're observed, are essentially differenced out for any given individual. Ideally, it's not supposed to make a difference because the layoffs are supposed to be exogenous, but they could still be confounded, so we wanted to do this check with fixed effects. Age in year in a fixed effect model are for the most part collinear within person, but we're still going to control for both to get maximal control. Plus, we allow age to have a squared term because it's not a linear relationship. And just of note, the people who didn't have a layoff, they're still in the model, right? Because they contribute to the estimation of the underlying age and time trend. Okay, so this is women, those year models, and random effect versus fixed effect. We were pretty surprised by this. So quite shockingly, the fixed effects estimates, if anything, they're a little higher, and we didn't lose power either. Usually you lose a lot of power with fixed effects. So we thought this was reassuring, or potentially reassuring, or supportive of the fact that these layoffs we're looking at, they really are exogenous, right? They're not contaminated or confounded by a bunch of unobserved factors. This is the 6-month version comparing random effect to fixed effect. And again, not a huge difference between the two. You guys are so quiet. You must be believing everything I'm saying. I'm used to being interrupted every 7 minutes.
We're much more well-behaved than
Yeah, and the Chicago people. Okay. This is the 4-month version. Again, random effect, fixed effect. Okay? All right, so you might be wondering, oh, these coefficients you're showing me, like, are they meaningful? Like, what's this 1.5, 0.2? Does that mean anything, right? So, I've been regressing on BMI for a long time. And in the world of regressing on BMI, a coefficient of 0.2 is, it's not that bad. So what I did here was I gave you a comparison to the estimates for education from the same model. These are random effect models, right? So bear in mind, it's a mixture of between and within effects. And here are our estimates for the layoff dummies, and here's education. And so it's comparable to the difference between having graduated from college versus the other education categories. So I'll let you make of that what you want, but we do generally think that education is very important for weight status and obesity. Okay? Just gonna let that slide? Okay. Good. Okay. Now, we also just want to take a quick look at, what if we look at weight status as a categorical variable? This is just a logistic regression model instead of a linear model. And we looked at 2 cut points. So one was a BMI of greater than or equal to 30, which is the cut point for obese, and BMI of greater than or equal to 25, which is the cut point for overweight, right? So we're calling them overweight or obese. Everything else is the same. And what we found was basically that the more sensitive cut point was this, 25. it's pushing people over 25. It's also pushing people over 30. There are positive estimates, but it's not quite as strong. So I'm going to show you just 2 slides on the 25. Okay, so these are odds ratios, and again, these positive estimates somewhere in the 1 to 2 year range, and 45% increase in odds of being overweight or obese if you had a layoff. So these are odds ratios, right? They can overestimate relative risk. And that's the 4-month version. Again, somewhere in here, one significant estimate, 56% increase in odds. Okay, so then we thought, okay, what could be some mediators to look at in this situation? So before we had just adjust for age, year, education, and race, ethnicity in the non-fixed effects models. But what about marriage, income, and employment? Okay, so these are fixed effects models, and this is what we saw before without adjusting for these things. If we add marriage in here, so married people are more likely to have a higher BMI, we know that, and that's positive and significant here. And not much attenuation. If anything, it's getting bigger. And this is quintile of family income over the past calendar year. Okay? And we put it in there, and it didn't really do much. But I'm going to say something about the income measure here, right? It's a little complicated because we're seeing these weight changes, somewhere between 1 and 2 years after a layoff. The way they measure income in this survey is what was your income in the past calendar year. So it's kind of not a sensitive enough measure to capture some, acute change in income necessarily, right? We need something a little more fine-grained. The other interesting thing about income is, look, most of the contrast is between the 5th quintile and everything else. Yeah. So, right. So I thought maybe this is because it's a fixed effects thing, but it's that one was a random effects model. Right. So this is going to be changes of income. So it's changing from the 5th to anything else that seems to be a big deal. And if we put employed in there, it has the right direction. So people who are employed have a lower BMI, but it doesn't fully attenuate the layoff stuff. So maybe it's not all about employment. Maybe it's also a component of underemployment is going on here. At the time of the survey. The same time their BMI was assessed. Okay, and we also threw in income from your own wages and salary in the past calendar year, right? But the same measurement issue in terms of it was over the past year. And your hourly wage at your current or most recent job, we also put in there. It didn't really make a difference. And we tried to look for interactions with marriage, employment status, family income, hourly wage. There's nothing significant, but there was a suggestion that the association might be stronger among people who are unmarried and the people with higher wages, which seems to make sense, or you could tell a decent story for that. And just a few quick slides on what happens if we stratify by race. If you look at the actual interactions, sometimes they're significant, sometimes they're not. This is a stratification. Non-Hispanic white women, non-Hispanic black, and Hispanic women, which tend to look more similar together. This is the 6-month model. And for white women, right, we see this strong positive effect or positive association at these intervals. And, definitely smaller for the other group, not significant. Don't know if it's a power issue, right? We keep cutting the sample. We're definitely losing power here. So unclear exactly what's going on here. This is if we do the fixed effect version, right? It gets even stronger for white women. And here again, we have this kind of not clear what's going on. I think it's undetermined. And the 4-month version. Fixed effect. Okay, too many tables. All right. The last piece we wanted to do was let's look at actual change in BMI. So all we did here was change the outcome. The rest of it is the same. Now the outcome is the subsequent survey year's weight minus this survey year's weight. Okay, so it's WIT plus 1 minus WIT. T plus 1 is the next survey year where we saw a BMI. And just as a reminder, those are the years when we have BMI. I recoded it, I scaled it to represent BMI change per year. And if we allow for 1 to 3 skips, right, it's like you missed one, we'll pick up your next one, but we're dividing it by number of years. Didn't seem to make much difference. Okay, this is just the distribution of that new outcome variable. This is change in BMI per year in sequential surveys. So lots of zeros, right? It's on average 1 or 2 years between surveys, lots of zeros. But the mean is 0.24, so that's 0.24 BMI units per year people are changing. So that, that adds up. That's how we got to our obese of whatever it was at the end. And the interquartile range shows that there are people losing weight, but there are more people, shifted towards people gaining weight, which is what we expect. This is what it looks like for white women. So the mean is a little bit lower, 0.22, and the interquartile range is maybe slightly wider. And what do we find? This is what we found. So these are the random effect model, fixed effect. This is for white women. We found a positive association in the first interval, and nothing after that. Okay? And, okay, I want to say 2 things. One, this 0.137, right? Remember, the average change per year was 0.22. So 0.137 on top of that is like a 50% increase over the average change. Okay, so that seems meaningful to me. And it kind of makes sense that what we see is an effect in the first interval, because what we saw was that something happens 1 to 2 years after your layoff. Okay? We're also measuring weight change 1 to 2 years after your survey. So it makes sense that when we're looking at change, the indicator is going to pop up in the one that's closest to the survey year. Does that make sense? Okay. It also shows, by the way, that we're not, this isn't consistent with the diminishing story exactly either, because then we would see a negative losing weight going backwards. So basically we found that layoffs are associated with increased weight status for white women, but these increases don't appear to endure. So maybe that's true. Maybe they gain a little weight, but they recover. They don't keep this weight. It's also the case that these data are a little bit crude, right? So if you think about what we did compared to what the labor economists do in some of their studies, we don't see people's layoff every weight status every 6 months, every 4 months, every 12 months, right? We only see their weight status every 1 to 2 years, but we have precise date information on when they got laid off, which is why we can manipulate it into doing these indicators. So, the data are a little bit sparse compared to how you might otherwise model this question. It's also the case that a lot of the people in this data, it looks like they went back to work relatively quickly. So I think in today's economy, there might be much longer spells of unemployment. And we also found that these layoffs are associated with a change in weight status for white women. And we have, once again, further evidence of sex and race differences in the relationship between weight status and labor market outcomes, but in the other direction, right? All those studies by economists before were on the effect of weight status on your labor market outcomes. Now we're showing a labor market outcome having an effect on your weight status. But I would love to to throw some ideas around after on why white women? What's going on here? And what are some potential mediators, right? So, given that although the measures weren't great, we didn't see a lot of stuff going on with income, wages, salary, that kind of stuff. So, maybe it's something like depression, social isolation, changes in time allocation, right? Maybe something like that is going on. And there's a lot of different ways you can model this. Just one idea might be to look at BMI as a growth curve model. You can turn this into a 3-layer data set with each layoff counting as a separate layer. We thought, I'd welcome your suggestions on this. Maybe it's interesting, we're losing this identification piece, but maybe it's interesting just to look at job displacement in general and what that does to your wage status, right? Given that it's such a big concern now. And just, look at that in addition to the layouts, which was really about getting at a cleaner identification. And we could focus on longer spells of unemployment or depressed wages, and we can look at whether there are, differences or changes by occupation or industry. So that's what I have today, and welcome any questions.